Hey everyone, it's Chaz. Welcome back to the channel. Hope you're ready for some more problem solving in LeetCode, because in this video, we will be looking at the two-sum part 2, where the input array is sorted. So this is considered a medium problem on LeetCode, but... Alright, so let's look at the problem statement. There's a lot here. Let's just read it first, and then we'll figure out what's going on. So it says, given a one-indexed array of integers called numbers that is already sorted in non-decreasing order, find two numbers such that they add up to a specific target number. So just like the first two-sum problem, we're just given an array and we're given a target, and we have to find two values in the array that add up to the target. It says a one-indexed array, but we'll worry about that a little later. The main thing that's going to concern us this time is that our solution must only use constant extra space. So that's going to be different from the first two-sum problem, which was the first LeetCode problem we did on this channel. In that problem, we used a hash map to store the values. Lucky's here. In the first two-sum problem, we used a hash map to store the keys and values, and that worked out great. The problem is now we have to use constant space, and a hash map is going to get bigger as our array size gets bigger. So it's going to be linear, big O of n, and we don't want that. So for this problem, we cannot use a hash map. We have to find another way. Fortunately, since the array that we're going to be given in this problem is going to be sorted, we can take advantage of that fact and accomplish this task with constant space. Let's take a look at a couple examples just to make sure we still understand the two-sum problem. So here we're given an array of numbers and a target of 9. I can see that the 2 and the 7 are the values that add up to 9. Normally we would return index 0 and index 1, but in this case, we're told that the array is one indexed. So instead of returning 0, 1, we're going to add 1 to each of those, and we're going to return 1, 2. And then if we look at another example, here we have an array 2, 3, 4. The target is 6. It's the 2 and the 4 that add up to 6. And since we want this array to be one indexed, we will not return index 0 and index 2. Instead, we will return 1 and 3. Finally, we have an array with only two values in it, but these two values do in fact add up to the target of -1. So we return the index of each value, which is 1 and 2. All right, so we'll take a look at the constraints. First of all, numbers.length, the number of values in the array, will be at least 2. So that's good because the problem is called two-sum. We do need two values in order to add up to the target. So if it were possible to have 0 or 1 value in the array, we would have to account for that. The values themselves within the array will be between -1000 and 1000. That doesn't really affect us. The numbers will be sorted in non-decreasing order, and that's going to be the reason why we're able to do this in constant space. The target value itself will be somewhere between -1000 and 1000, and the tests are generated such that there is exactly one solution. All right, so you've probably seen several times on this channel that we solve a lot of problems using pointers, and this problem's no different. We're going to use a two-pointers method. Let's start off with an example array here, and we'll say that the target is 9. So what we're going to do is create two pointers, left and right. We're going to place those two pointers on each end of the array. So we'll take our left pointer in yellow, put it at index 0 at the 5. I'm going to call this index 0, even though we said at the beginning that they want the array to be one indexed. We're not going to worry about that until the very end of the problem. And then we're going to put the right pointer at the end of the array. So this array is size 7, so we're going to put the pointer at index 6. Right, next we're going to check the sum of the values at the pointers. So next we're going to check the sum of the values at the pointers, and then if... It's so distracting. Now, before I show you the next step, let's just think about what we should do if our sum is too small. That means we want to end up with a larger sum. So we shouldn't move the right pointer because that'll just get us smaller numbers. That'll make the sum even less. So what we really should do is move the left pointer in order to get to a larger number in order to get closer to the sum. Now you might be thinking, well, hold on, because the 11 at the right pointer on its own is already bigger than the target. So shouldn't we move the right pointer? Well, the problem with that is we don't know what the values are in each array in the test cases. We don't know if there are a bunch of negative numbers in the array. So even though we could see here that there's only one negative number, we're not going to know that for every test case. So for all we know, the next value could be another negative number. It could be -2, and then 11 plus -2 equals 9. So no matter what, even if the value at the right pointer is by itself greater than the target, we need to watch out for negative numbers. So if the sum of the two values we check is too small, we're going to move the left pointer over. And then similarly, if the sum is too large, in order to get closer to the target, we need to get a smaller number into our sum. So we're going to move the right pointer in order to get to a smaller value in the array and get closer to the target. And then, of course, if the sum is correct, then we just have to return the index of each of those pointers. And because this is considered one indexed, all we have to do is return the index +1. So if we were at index 1 and 2, we wouldn't return 1 and 2. We would add 1 to each of those values, and we would return 2, 3. All right, so let's see our algorithm in action. So our left pointer is at -5. Our right pointer is at 11. -5 plus 11 is 6. 6 is too small. It's less than 9. So we're going to move our left pointer over in order to get to a larger number, which should get us closer to our target. So now we have the left pointer at 1 and the right pointer still at 11. 1 plus 11 is 12. 12 is too large. So we're going to move our right pointer over in order to get to a smaller value. So now we have 1 plus 7, which is 8. 8 is too small. So we move our left pointer in order to get to a larger value in the array. So now we're at 3 and 7. 3 plus 7 is 10. 10 is too large. So we will move our right pointer. And now we're at 3 plus 6, which is 9. Our target is 9. So we have found our values. Now all we have to do is return the indices. So I'll put them on the screen. We have to remember that they want us to return the one indexed indices. So all we're going to do is we're going to take all of these indices and add 1. So now instead of seeing the index of each value, we see the index +1. And so instead of returning 2, 4, we're going to return 3, 5. Now, even though the problem states that we're guaranteed to have an answer, let's just see what happens if there is no answer. So let's say that instead of the target being 9, let's say the target was 19. Eventually what will happen is we will reach a step where the left pointer is at the 7 and the right pointer is at the 11. And then 7 plus 11 equals 18. 18 is too small. So we'll end up moving the left pointer over. Our job is to find two values that add up to the target. So if the left and right pointers reach the same value, then we know that there is no solution. So we're going to use that as our condition to stop our loop. If the left and the right pointers end up together, then we should stop checking. All right, now let's go over the time and space complexity of this problem. Time complexity is going to be big O of n. It's going to be linear time, where n is the length of the array. And that's because in a worst case scenario, each value ends up being visited once. And then the space complexity, they required us to use constant space, and that's what we did. Space complexity is big O of 1. We created 2 pointers, and we also created a sum variable, and no other additional memory is going to be needed. So no matter how large the array is, we will still only create 3 variables. All right, well, at this point, I'm pretty confident that you could solve this problem. So get on LeetCode, write up your solution. If you get stuck, just come back to the video to get some more help. If you do manage to solve this problem, then please let me know in the comments below. All right, you ready? There's only one thing left to do. Let's code some Java. Our solution is going to start by creating 2 pointers, left and right. So I've got my integer left pointer, set it equal to 0, so it goes to the start of the array. And my right pointer goes to the end of the array, so I have numbers.length -1. Next, we have our while loop. We said before that if the left and the right pointers end up meeting, that we should stop checking for sums. So that's why my while loop just goes while left is less than right, because this way, if they ever become equal, I know that my code will stop running. So here I create my third and final variable, the sum equal to numbers at left plus numbers at right. So whatever the value is at the left pointer plus the value at the right pointer. And now I have my if block. So I say if the sum is less than the target, if the sum of my two values is too small, then I should move the left pointer in order to get to a larger value. And then if the sum is actually greater than the target, I have my else if statement, which says to move my right pointer back in order to get a smaller value to get closer to the target. And then finally, I've got my else statement to cover the remaining situation, which is when the sum is equal to the target. I just wrote that as a comment just to make it clear that that's what the else statement is checking. But in this case, if I found my target, then all I have to do is return the left and right pointers. And then since the problem says that the array must be one indexed, I'm going to return, instead of left comma right, I'm going to add 1 to each of my pointers and return left plus 1, right plus 1. And then, as I'm sure you know by now, since our return statement is inside of an if block, it's going to be localized to that block. So according to Java, we are missing our return statement. So there's one last thing we have to do outside of the while loop. We need to return a new int array. And in my case, I just returned an array size 2 with nothing in it. If you wanted to, you could copy the return statement from line 13 and paste it on the line 16 and just return the same thing, left plus 1, comma, right plus 1. You could return -1, comma, -1. As long as you return some kind of integer array or throw an exception, then the code will compile just fine. In our case, since we know that there will be exactly one solution, we don't really need to return anything specific on line 16. But if the problem told us, for example, if there's no solution, return -1, comma, -1, then that's what we would do here on line 16. All right, so that's it for this video. Hello again, Lucky. Please like and subscribe to the channel. Oh my God, why am I so bad at this? Basically, if you want to see more of him, then you need to subscribe to the channel. You need to like this video, share it with your friends, comment down below, and that's it. I will see you. Let's get some food.